Alright, so I'm gonna desolder the hex inverter here. I did not get a vacuum desoldering station, so that'll just have to be a later video if I can never get one of those. But I end up just using my regular soldering iron and a solder sucker, and eventually I actually do get the hot air rework station out on it, which actually proved to be really handy for that. It really helped a lot. But once I get it removed, we'll go ahead and go into putting the new one on and getting it soldered up, and we'll see what happens. So we've got the meter pulled apart, and we desoldered the hex inverter. It was a little bit tricky. I'll kind of go through some voiceover on doing it, what all it took, but the hot air rework station actually did help me out a lot. And I'm just looking at the traces here, and most of the traces that actually involve the inverter are on the bottom side of the board, but I do see that the positive lead of my battery comes in and feeds obviously the main input on that chip, and then it comes across to, looks like this transistor here, and then it actually keeps carrying on, and I'm not too concerned about where it goes after that. But I do see that my ground lead comes around to here, so I think that explains kind of why the chip was getting so hot, because if we do have a short in it, then it's carrying that short all the way across the chip, and so the entire chip is just burning up. And then there's a little jumper here, and then this leg here looks like it goes out and comes across and actually goes to what looks like the continuity buzzer. So it just may be bringing power into that. And other than that, this ground goes to this resistor here, which this resistor is probably going to something way out here, and actually just using this as a ground leg and letting it flow through. But I think we'll get the microscope out and inspect the top side of this now that it's a little bit more accessible, and then we'll go ahead and solder the new chip on and see what it looks like. By the way, this is what the bottom of that chip looks like. So I'm not surprised that it's shorted out. Now that I've seen that, was surprised at first, but I'm not anymore. Alright, here we go. We're getting nothing. Alright, so we're still not getting anything on it. I'm actually pulling the board off and gonna try to look at other stuff. The hex inverter is no longer the problem. I've actually thank you. Surprise! Let's see what this is. I think this is Legos. That's for something not electronics related. The meter still isn't working. I'm getting nothing on the display. I have actually checked the hex inverter on the oscilloscope. It's no longer getting hot, and it is inverting signals. It has a 60 hertz signal coming into it, which matches the clock crystal signal. So I'm not sure if that's the right frequency. I would have thought it would have tended to be a little bit higher, Maybe something is going on with the clock crystal. Still haven't got any schematics on this, so I'm still just kind of working in the dark on it. But the hex inverter is definitely working properly. I have also measured the current that it's consuming whenever it is turned on, and it's only about 0.1 milliamps, which is extremely low. I would expect something, the Fluke 12B, I measured it just to kind of get an idea, and it's pulling about 1 full milliamp whenever it's on. So it's drawing a really low current. So I'm thinking that maybe there's something open in here that's not turning on. I'm kind of suspecting possibly these transistors here. Maybe even these electrolytic capacitors are bad. But I'm not leaning towards them yet. I am leaning a little bit more towards possibly these transistors, or maybe just these resistors are open. I've toyed around a little bit with some stuff, and nothing is really jumping out at me, so this may end up getting put on the side for a little while I'm hopefully going to get schematics for it. But as of right now, the hex inverter is changed and the meter is still not coming on. Okay, so I went ahead and kept playing with the meter to see if I could try to make heads or tail out of anything happening with it. And I've also kind of hacked in another clock crystal onto it just to see if that would make any difference at all. And it actually didn't. I was still getting the same frequencies, the same 60 hertz frequency that I was getting before, which I was really expecting something different because it is a different clock crystal. And the top of it says 4.000. I believe that that's going to be a 4 kilohertz crystal. So I was expecting something in that neighborhood, but it was the exact same signal that I was getting as before. So that was something that kind of mystified me. And another thing that I wasn't doing was putting the range switch onto the meter whenever I was testing things, because it does actually get direct power from the battery when it's hooked up to the hex inverter. So I was expecting that would be enough to test it. But I decided to go ahead and try to put the range switch on it and just leave it in the off position. But even in the off position, the hex inverter actually seemed like it was shorting out again. And I may have actually burned it up. It was getting really hot, so I may have to change it again. But before I change it, I really want to find out what's going on here. You know, I'm not sure what could be causing this to happen to make this inverter overheat like it is, and for this frequency to seem so off. So for right now, the meter's going to go back in a box until I get a little bit better at this and learn a little bit more. Anybody that has any ideas is more than welcome to put them in the comments. You know, anything that I can figure out to check, I would be more than happy to check it out. But as of right now, I'm stumped. They can't all be winners. This one doesn't seem like it's gonna be. I am willing to go a lot further down the rabbit hole with this. You know, get replacing parts and stuff, even more than the meter's worth, just as a learning experience. So anybody who has any ideas, even if it's something that is fairly costly to replace, I would definitely entertain any thoughts of that. So thanks for watching, and I'll see y'all for the next project.